We're going to get through the rest of the methods of factoring. So after today, you will have officially all of the factoring methods. And one of those methods is something that you guys actually already know. You just, you didn't know we were doing it. I tricked you into doing it. So just an FYI, one thing will be super easy today. One thing will be a little harder. But first step to factoring anything, if I look at this first one, what's step one? GCF. What's my GCF here? 9. And what would I be left with? Perfect. X to the 4th minus 4. And then this is a binomial. So as of right now, the only thing we can do with a binomial is a difference of squares. That'll change today. But is this a difference of squares? Yeah. What's the square root of x to the 4th? X squared. Remember we cut those exponents in half. What's the square root of 4? 2. So I'm going to keep my GCF, keep the 9. Don't drop it. And then I get x squared plus 2 and x squared minus 2. And then I check again. Are either of these perfect squares that I can do a difference of squares for?
No.
No, 2 is not a perfect square. So I stop at this point. But I am mentally checking to make sure that I can't do anything else with those. Okay? Questions on that one? Okay. Next one. Right off the bat, what's weird about this? Yeah, but before we even get to that, yeah, it's out of order. We got to put it in standard form first, so we're at least more used to what these things look like. So I'm going to reorder this with the negative 4x to the 5th first. And now it's something with our descending exponents, and we can kind of handle it from here. First step to factoring anything, what should I do? GCF. What's my GCF here? X. Okay. If I pull just an x out, I'll be left with a negative 4x to the 4th as my first term. My recommendation is to always keep your first term, that leading coefficient, positive. So instead of pulling just an x out, I'm going to pull a negative x out just so I don't have to deal with the negative 4 right here, and I can change it to a positive 4. If you don't pull the negative out, you'll still get the same answer. On one of your factors, your signs will just be switched, but it would still be correct. It just might confuse you once we actually do the X method and set stuff up. So I would take the negative out right away if you can. Then that's going to switch the sign on the last two as well. So minus x cubed minus x squared minus 18. Good on this step. Then I say binomial or trinomial. Trinomial. So we set up our x. And like Brooke said, we have to multiply to negative 72 and add to negative 1. What do we think?
9 and negative 8.
Very good. 9 and 8. Which one's negative?
8. Oh, negative
9. If you did not pull a negative out, then the 8 would be negative and the 9 would be positive. So just be aware, if you didn't pull the negative out, your work so far might look a little bit different. Now, technically what I'm about to do is stuff that technically is we're learning today. But what I'm going to do is rewrite this middle term, as we've been doing, as 8x squared minus 9x squared minus 18. You can put those in any order. I chose this order because I automatically see I can pull a 4 out of these first two. But any order will work. You'll get the same thing. So just replacing that middle term. Then, what do I do from here? Not quite yet. Yeah, split it into 2 groups and then take the GCF of each group. So I split it into 2 groups. I keep my negatives with the second group. So if there's a negative as that third term, it goes with the group. And now I pull out a GCF. I would just be extra careful and really show like where you're separating your original GCF from this new stuff that you're about to factor. So I'm going to kind of show that with brackets. This is where my original GCF was, and everything after that is stuff that I'm still working on. So out of the green parentheses, what is my GCF?
4x squared.
4x squared. And I'm left with x squared plus 2. Now I have to take something out of the purple to be left with x squared plus 2. Negative 9. Again, taking the negative out because we want that leading number positive. So negative 9, I'm left with x squared plus 2. I'm going to kind of hop down here. I'm keeping my negative x out in front. That was from step 1. That GCF follows all the way down. X squared plus 2 is my matching parentheses. So that's a factor. What would my other factor be?
2x minus 3.
Yeah, 4x squared minus 9. How did you get 2x minus 3? You're not right.
You have to do the perfect square.
Yeah, this is a difference of squares. So I could just stick it right in and then add a new line for my work, but I'm just going to do the difference of squares right now. Braden.
Could you put the negative x in front of the 4x squared minus 9?
Sure.
It doesn't matter.
Yeah, and your final answer, the order of these at the bottom doesn't matter. But instead of putting this in and then doing difference of squares, I'm just going to do it before I put it in as my answer. So the square root of 4x squared is 2x. What's the square root of 9? 3. So I get 2x plus 3 and minus 3. And yeah, like I told Braden, these can go in any order. Typically, the GCF that we pulled out stays in the front because there's no parentheses around it. But technically, anything can be switched around in there. Questions on that one? What this type of factoring is, when you go from 4 terms to groups to pulling out a GCF and then regrouping, that's called factor by grouping. And that's the first thing we're going to talk about today. So when we have 4 or more terms, like in this case, we created a 4th term. And there's a GCF present in those 2 pairs. Like here, the GCF was 4x squared. Here it was negative 9. So if you have 4 or more terms and 2 pairs of things have a GCF, then we can factor by grouping. Long story short, if you have 4 or more terms, you factor by grouping. Okay? And when you group, you do the exact same steps we've been doing for the past 3 days. You split it into 2 groups. So we did these 2 and these 2. You pull a GCF out of each group. Your parentheses should match. So that's what step 3 is saying. You should have matching factors. And then you put that matching factor and the GCFs that you pulled out back in. And that's it. So this technically is not new. We are just now, instead of creating a 4th term, it's going to be given to us. We're going to start with 4 terms. But we do everything the same. So step 1 is still find a GCF for all 4 terms. In this case, do I have a GCF? No. Step 2, I group. I see I have more than 4 terms, so I'm going to group 2 and 2. And the rest is stuff that we've done. What's the GCF of my green group? X squared. And I'm left with x minus 2. What should I pull out of the purple group to be left with x minus 2? Yeah, negative 9. X minus 2. So one of my factors is for sure my matching parentheses, x minus 2. If those parentheses don't match, something wrong happened. You got to go back, try again. You probably pulled out the wrong GCF. So x minus 2. And then what's my other factor? X squared minus 9. There we go. Difference of squares again. X minus 2. X plus 3. X minus 3. And then again, we check. These ones, the exponent is 1 on all of them, so I know I'm done. And I can check again. My exponents should add to 3. 1, 2, 3. So we're good there as well.
Is this all it is?
That's all the first page is, yeah. So, since you guys are kind of used to it, I want you to try this one on your own. Okay, we'll do the bottom two together, but try this one on your own. There's no GCF, so just go straight into grouping. Yeah, you've done it before, we just technically haven't called it factor by grouping. Because you're subtracting your exponents, not dividing. Huh? Just this one, yeah. The bottom two we'll do as a class. Okay, I already split it up into two groups. From my green group, what can I pull out as a GCF?
X squared.
X squared. And I'm left with x minus 3. From the purple group, what should I pull out?
Negative 16.
Negative 16. Left with x minus 3. My parentheses match, so that's good. I leave that as part of my answer. And then I would have x squared minus 16. That's a difference of squares. What can I break it up into?
X plus 4, X minus 4.
Perfect. X plus 4, x minus 4. Double check. I have 3 x's, and I need an exponent of 3, so I'm good. Questions on that one? Okay, next one. Before we group, what's step 1?
Usually, yeah.
GCF. What's my GCF for this one? 2 and
X.
x. Perfect. 2x. And again, just to kind of keep my GCF separate, I'm going to use brackets instead of double parentheses. I'm going to use brackets to kind of show that it's clearly separate. And then what's left would be 3x cubed minus 4x squared plus 3x minus 4. And then I group. So I'm still kind of ignoring the 2x. I'm just looking at the things in the brackets. There's 4 terms, so I group 2 and 2. From my green group, what's my GCF? X squared. I'm left with 3x minus 4.
Isn't it minus 2? Oh, minus 4.
Minus 4, yep. And now I need to pull something out of the purple group to be left with itself. Natalie says 1. I agree. We're dividing. So 3x minus 4 divided by what number gets me 3x minus 4? It's 1. So I pull out a 1. I'm left with 3x minus 4. And then I regroup. Again, my GCF from the very beginning follows me all the way down. The 2x is still there. The 3x minus 4 is there. And the x squared plus 1. Then I check. The first 2 factors I can't do anything with because the exponent is only 1. What about this one? No, it's a sum of squares, which doesn't exist. So don't try to break that up at all. Okay, we have to leave it as it is. And then we can double check still with our exponents. I have 2 plus 1 plus 1. That gives me my x to the 4th. questions on that one? Same stuff you've been doing, you just now are given 4 terms instead of creating your own. Or you could be given any number of even terms. Here's 6. We do the same thing. First, do I have a GCF for all 6 terms?
No.
No. So now I'm going to group them into 2 groups of 3. So if you have 6 terms, you have 2 groups of 3. If you have 8 terms, you have 2 groups of 4.
What if you had 7 terms?
You can't do it. And I will never give you an odd number of terms.
Can't you like group them together? Like there's a 2a squared and a 9a squared.
Those are not like terms, though. Do you see how this one has a B and this one doesn't? So like we could rearrange and regroup, but we can't just add those together.
You do 3 groups of 2.
Yeah, should work out the same way. I actually have not tried that, but it should work out the same way. So, group and group, okay. GCF from the green, what do we got? A. And I'm left with 3a squared plus 2a minus 5.
Can you? Oh, I thought it was one.
What about here?
3.
3 and B. And I'm left with that same thing, 3a squared plus 2a minus 5. My parentheses match. That's one of my answers, the 3a squared plus 2a minus 5. And the other piece, the a plus 3b. Should I stop right here and call it a day?
No.
No, I have to at least check to see if I can factor this trinomial. So, let's set up our x method. I need 2 numbers that multiply to my middle number, 2. Again, I'm ignoring everything else except for this trinomial.
5 and 3.
Sorry, add to 2, multiply to negative 15, and then what 2 numbers did I just hear? Yeah, 5 and negative 3. And now I'm going to have to do grouping again because A is not 1. So I have to rewrite my middle term and group again. So my A plus 3B stays. It's done. It's going to follow me all the way down. This piece I can rewrite. So I'm going to rewrite it as 3A squared minus 3A plus 5A minus 5. You could put those in any order. I'm choosing this order because the 3s clearly, they have a GCF. So this is like a grouping inside of a grouping. We grouped, and now we're going to group again. So, put the first 2 terms together, put the second 2 terms together, and find a GCF for each. So for the first green group, what's my GCF? 3A. And I'm left with A minus 1. For the purple group, what's my GCF? 5. I'm left with A minus 1, which is good. If that didn't match, I would have to go backwards. And now my final step is just putting all my factors together. A plus 3B, that came from the very beginning. I have my A minus 1 and my 3A plus 5. And again, we can, 2 hands. Seamus, go.
When we originally got like the A plus 3B, is it fine if I just like put it at the bottom and I don't keep rewriting it? If it doesn't change anything.
If that's a risk you are willing to take, sure. I will say, if your bottom line is really messed up, it might be hard for me to give you partial credit above. So, do with that what you will. What other question do we have, Musab?
Will we ever get to the point where we do all these steps and at the third one we're gonna have to do more?
Maybe.
Come on.
It might be like 4 steps. Who knows? We're not done until we're done. Happens. Okay. How do we feel about grouping? 4 more terms we group. Give me like a thumbs up, sideways down. Decent. It's not super new. Not bad. Here's what's new. Before today, before this very moment, all we could do with binomials was what? What was our only option? Difference of squares. Starting right now, we have 2 more options. Difference of cubes and sum of cubes. Before we talk about them, I want you to erase, not erase because you can't erase, but cross out, black it out, whatever, these 2 things. I typed it wrong. Get rid of them. Erase them.
Like the whole box.
Not the whole box, just the A plus B and the A minus B. If you have a friend that's not here, tell them to erase it when they come back. So, fresh start. Okay, if we remember, for a difference of squares, we had A squared minus B squared. So a sum of cubes is going to be something cubed plus something cubed. We'll get A cubed plus B cubed. We're starting with a perfect cube plus a perfect cube. For difference of cubes, A cubed minus B cubed. Before I talk about these patterns, let's talk about what numbers are perfect cubes. Like what numbers I should be looking out for to use this factoring pattern. Hold on. What's 1 cubed?
27.
Let's go in order. What's 1 cubed? 1. What's 2 cubed? 8. What's 3 cubed? 27. 9 times 3. What's 4 cubed?
36.
48.
64. See, I would write these down because we're struggling. Okay, we got 5 cubed. 5 times 5 is 25 times 5. 125. Good, good. Okay. The rest, I don't even know off the top of my head most of the time. So 6 cubed is 216. 7 cubed is 343. 8 cubed is 512. 9 cubed is 729. We know 10 cubed. 1,000. Whew. Okay, good. Good. So, anytime you see numbers like this or a variable cubed, you should be thinking maybe difference or sum of cubes. Okay. Just like difference of squares, these 2 you'll have to memorize. I'm sorry. These ones are longer. They're more difficult to memorize, so just bear with me. Both of them, sum and difference, sets up the same kind of terms. The only thing that's different is the signs, the plus and minus signs between the terms. So the terms is the hard part to remember. The plus and minus signs, I'll give you a trick to remember. Here's how the terms work. Just like for difference of squares, we take now a cubed root of both of those terms. So let's talk about what that means really quick. For square roots, I said that's the same as raising it to the 1/2 power. Like the square root of x squared was x. So if I'm looking at a cubed root, what power am I really raising it to?
1/3.
1/3. So the cubed root of a cubed is just a. So if I take the cube root of each of these terms, I just get a and b. So step 1, take the cube root, write it down. Step 2, those cube roots, and again, we'll handle the sign later, but the cube roots go together in the first set of parentheses, AB. Then we square each one and stick it in the front and in the back. So A squared goes in the front, B squared goes in the back of the next set of parentheses.
Wait, why are we square now?
It's the rule. You got to memorize it. If we don't square it, we will never get a cubed. We'll just have a squared total. So we need those exponents to add, right? Okay. So that's part of it. Then your middle term are these 2 numbers multiplied together. So A times B. AB. So that is your general kind of setup for any difference or sum of cubes. That's the hard part to memorize. Luckily, it's the same for both. Easier part to memorize is what signs go in between. We have an acronym. It's called SOAP. It will help you. It'll tell you what signs go where. The S stands for the same sign, meaning if we start with a plus, we put a plus in there. If we start with a minus, we put a minus. So plus and minus. Same sign, same sign. The O stands for opposite sign. So if we started with a plus, we now put a minus. And if we started with a minus, we put a plus. The A and the P go together for our last one. It means always positive. So that one's easy to remember. There should always be a plus sign at the end. And those are the two things you have to memorize. This and this. Plus your difference of squares. Okay? But they work the same way as the difference of squares. You basically take the cube root and then you start plugging and chugging the rest of the way. Okay? Questions on that setup? Okay, let's do one. Let's look at x cubed plus 8. Again, nothing else in our flow chart is changing. So step 1 is still GCF. Do I have a GCF here? No. Step 2 is I go to binomial for 2 terms. And I see a plus sign, so I know it can't be perfect squares. It has to be perfect cubes if it's something at all. So what is the cubed root of x cubed? X. What's the cubed root of 8? 2. So now if I kind of relate it to my general form up here, A is x and B is 2. So anytime I see an A up here, I'm going to put an x. And anytime I see a B, I'm going to put 2. So let's do it. 2 sets of parentheses. A and B go together, so x and 2. Again, I handle the signs at the very end. So then we do A squared, so x squared. And B squared, so 2 squared is 4. That handles the front and the back. In the middle, we put x times 2, so 2x. And now we use our handy SOAP acronym for our signs. Same sign, opposite sign, always positive. Am I done at this point?
No.
No, what would I have to do?
Do the GCF again.
Not GCF, but I would have to at least look at this trinomial and see if it factors. I'm giving you permission to never look at that trinomial because it will never factor, okay? So this piece right here, no matter what, is never factorable. So once you get a trinomial from a sum or a difference of cubes, you can stop, at least on this piece. The binomial might need some work still, but the trinomial, you're done. You'll never be able to factor it, okay? So just don't waste your time. That part is not factorable. Questions on that example? Okay, I want you to try just this one right here on your own or with the people around you. Actually, let's do both of them. Let's do these two on your own or with the people around you. And then we'll reconvene in a few minutes. Yes. Yeah, go ahead. There's a pass. Yes. So when you take the square root, you don't care about the sign at all. So it's just positive 5.
Okay.
I tried the wrong one.
Ava just made a really good point. When you are taking the cube root of these things, we ignore the sign in the middle. Okay? The sign in the middle is going to be handled by SOAP. But when we take the cube root, we're not taking the cube root of negative 125 and getting negative 5. We're just taking the cube root of 125 and getting positive 5. Okay?
Yeah, wait, no, you did it. Wait, actually, I don't know. No, you did it.
This is what you should have gotten for the first one. Your cube roots were x and 5. So x plus 5 times x squared minus 5x plus 25.
That's x minus 5, right?
Yeah.
Just the same.
Ah!
Oh.
Sorry. You're right.
And then the second one is a plus by 5.
Hold on. Minus plus plus. That's what you should have gotten for SOAP.
Alright, so
Whew. And then for the second one, x and 1 are your numbers. And then same sign, opposite sign, always positive. And then we stop. We don't even care about checking this trinomial. We know it can't be touched. Questions on those two?
We got it
So,
for
like,
today.
after this, you don't do nothing else.
Not with the trinomial. In here, there's always a possibility of something else going on in here for the binomial. But for the trinomial, it's done.
Okay.
So would you do difference of squares?
Yeah, if this was like x squared minus 1, for sure. For sure. Okay. Let's hop up to this one. 27x cubed minus 64. First step, GCF. Do I have one?
8, yeah, 9.
No, 9 does not fit into 64.
No.
So no GCF. So I go straight into difference of cubes. I know it's cubes because I have an x cubed. Okay? What's the cube root of 27x cubed?
3x.
3x. What's the cube root of 64? 4. So I stick the 3x and the 4 in, and here's where I have to be slightly careful. One of you will mess this up on a test, I promise you. Someone's going to mess this up. When I square this, I'm squaring both pieces. So 3x squared is 3 squared and x squared. So it's 9x squared. You have to square the whole thing. The whole thing. 4 squared for the last piece is 16. And then 3x times 4 is 12x. And then SOAP, same sign, opposite sign, always positive. And that's it. Questions on that one? All right, do this one on your own or with the people around you. Careful, your A is going to have like a number times x. So when you square it, you got to square the whole thing.
Doesn't have a GCF though?
No GCF. Or yes, GCF. Yes, GCF. Pull out a GCF first. Cute shoes.
Thank you.
Very cute.
They're handmade.
Did you paint them yourself?
No, my friend did.
Fun.
Super cute.
Super cute. They look like professional.
She's
Yeah, I can tell.
But you said that there is a
yeah,
There is X.
So what was the GCF?
There is a GCF.
Wow, it's 2.
Yeah.
What does it say?
So
2x.
two.
Yeah, square. You had it. I knew what you meant.
So is it 2?
Yeah.
Or 2?
Choose this big.
wait, and what do I do after?
Squared.
Like,
After
now
your
I have
GCF?
parentheses,
Now we have parentheses. Let's pull out something else. What about my x's? Pull out some x's with them. And then you'll be left with some cubes. There.
You do 2x.
It'll take like 30 seconds, but yeah.
It'd be 2x squared.
Okay. What is my GCF here? What number can I pull out? A 2. How many x's can I pull out? Yeah, squared. Okay. I would be left with 8x cubed plus 27, which is a sum of cubes. Cube root of 8x cubed is 2x. Cubed root of 27 is 3. Peter.
Doesn't 16 go to 54?
No. 16 goes into 48 3 times. And then times 4 would be 64. So no. Okay. So, again, be careful. Make sure this original GCF stays with you the whole time. It goes all the way down. And then I have 2x and 3. I have 2x squared, so 4x squared. 3 squared is 9. And then 2x times 3 is 6x. And then SOAP for our signs. Same, opposite, always positive. Questions on that one? Okay, second to last one, I'm going to add one. You'll see why. But second to last one, GCF here. What do we think?
3.
Yeah, 3x.
I have a question.
Yeah, what's up?
For the last one, so, if we change, the positive or, subtraction for, when we do greatest common factor, would we use the greatest common factor, equation to?
I don't know what you're asking me. Can you restate that?
You know-
Like if we pulled like a negative 2x out instead?
Yeah, and,
Don't.
if you see in the parentheses, no, if you see in this parentheses, if you see like, it changes from positive, from the original equation to subtraction inside the parentheses, which one would we go?
Like here to here?
No, from the first equation, no, you have, first, on top, yep. And then that symbol changed when we put it in parentheses.
No, it didn't.
No, I'm saying if it did,
It won't. If it did,
yeah, if we,
it would only change if you pulled out a negative, which is fine, but then you would do difference of squares because this would be a minus, or difference of cubes because it would be a minus sign. But you would still do same sign as up here, opposite sign.
so we go by the one.
You go by whatever you're doing sum or difference of cubes on, yes. If that confused you, ignore it. But yes, you're going by whatever you're breaking down. That sign. Okay. 3x is my GCF. Okay, I'm left with x cubed plus 27. What are my cubed roots? X and 3, yep. My GCF stays 3x. X and 3 go together. X squared, 3 squared, and then 3x. Same sign, opposite sign, always positive. There's one more example I want us to do because I didn't think it showed up in your homework tonight, but it does. So we're going to talk about it. What if we had something like 4x to the 6th minus, trying to think of a good number to pick, 64. X to the 6th minus 64. Get rid of the 4. X to the 6th minus 64. Okay. This x to the 6th. What's the square root of x to the 6th? x cubed. What's the cube root of x to the 6th? X squared. So with just the x to the 6th, I could go either way, cube or square. 64, I could also go either way. It's 4 cubed or 8 squared. I want you to always do difference of squares first, if possible. So here, I'm going to choose this piece, my x cubed. I'm going to take the square root of each. So do difference of squares first. So x cubed minus 8 and plus 8. This gets gross. I'm sorry, Musab. You're not going to like it. What is this? Difference of cubes. What's this? Difference of cubes. So we have to do it twice.
Right, isn't that a sum?
Or sum of cubes, I mean, yeah. So we have to do this, but twice. So we have x and 2 as our numbers. For just the first one, difference of cubes, x and 2, x squared, 2x, and 4. Same, so minus, opposite, plus, always positive, plus. That's half of it. We have to do it again. Same numbers are going to go in, same terms. We're just going to switch all the signs except for the last one. So now we'll have x plus 2, x squared minus 2x plus 4. So just be aware. I didn't think it showed up on this homework. We'll talk more about this on Tuesday.
So is there 2 solutions?
Hmm?
Is there like 2 solutions?
No, this is your solution. You would type this whole thing into Delta Math. Sorry. That is it. Okay? So if you have something like that, an x to the 6th, there's something you could take the square root or the cube root of. Take the square root first. Yeah. Okay, rest of the time you have for homework.
Do we have to do this?
Oh, wait. Pause. Back it up. Go to this sheet. I'm sorry, Laura. We are now officially done with factoring steps. So let's fill out this completed flow chart. Step 1 is always GCF. That's not how you spell GCF. Okay. Step 2 depends on what?
If it's a binomial.
Yep, the number of terms. So if we have 2 terms, a binomial, we now have 3 options. We have a difference of squares. We have a difference of cubes. Or a sum of cubes. If it's 3 terms, if it's a trinomial, what do? Yeah, we do the X method. Maybe with some regrouping in there and some rewriting that middle term, but we do the X method. And then what we did today, if we have 4 or more terms, so 4 plus terms, we factor by grouping. And then at the very, very end, after we finished each step of factoring, we have to check. Make sure everything is factored as much as it can be. So, this assignment 2.5 is the last Delta Math assignment for the unit. The rest of the time we'll have worksheets. So you'll get a nice review worksheet on Thursday for your open note quiz on Monday. But the rest of the time is yours to do your homework. What? Yeah, wait till someone comes back.